Welcome to Dassault Systèmes' Sustainable Aviation podcast series. Dassault Systèmes Northern Europe is delighted to have launched its first ever Sustainable Aviation student competition, and we are very keen to explore, in this podcast series, the challenge the student teams will focus on, the future of propulsion. We will be speaking to experts in academia and the industry about their own vision to ensure the sustainability of flights and how the workforce of the future will help. Welcome everyone. My name is Shaneem Mizrahi at Dassault Systèmes, and I will be your host today for this episode of our Sustainable Aviation podcast series. I am delighted to be exchanging with experts in the aerospace field to tell us what the future of aviation holds, how they see the future of propulsion developing, and what are the skills that will be needed the most by the workforce of the future. Today, I have the pleasure of welcoming Stuart Dawson, Chief Technology Officer at the AMRC. Stuart has had a fascinating career, both at the former nuclear AMRC as its Chief Technology Officer and now as CTO for the University of Sheffield's Advanced Manufacturing Research Centre. He has over 20 years of experience in the aerospace industry, during which time he has led productivity improvements across a variety of UK aerospace firms, such as Kyocera and Unimerco. Thank you very much, Stuart, for joining us. We're delighted to have you today.
My pleasure.
So let's start right in with the first question. So what do you see as the biggest challenges or roadblocks in the aviation industry today?
Okay, I think there's two absolute enormous ones. The first being the absolute imperative to reduce emissions. And then there's also some technology challenges, and primarily among those are the fact that aviation fuel is actually a really excellent fuel source apart from its emissions. So I'd like to sort of tackle those two things separately. So the aviation industry is absolutely fighting a sort of perfect storm of pressures, both from the public and society in terms of the flight shaming movement, sort of that's been led out of Scandinavia by Greta Thunberg. And so the other side is that there's a whole raft of government legislation that's coming through that is prevent or disincentivizing high emission transport. So, for example, within the UK, by 2035, it's going to be illegal to sell any cars that only have internal combustion engines. So they've got to be either hybrid or electric cars. And of course, the UK has set into law its net zero 2050 legislation. And then on top of that, we've got activist investors, and we've already seen that banks and investors who are withdrawing from high polluting industries, such as coal mining and oil and gas. So could aviation be next on the agenda? So a whole raft of pressures focused around the industry's high emissions, so pressure from society, pressure from government, and pressure potentially coming from investors. And I think what's really sort of concerning for the aviation industry is that in the medium term, at least, its emissions are set to rise in comparison to other industries, because it's the decarbonisation / electrification of ground-based transport is going to happen a lot more rapidly. And so is the amount of emissions produced by the aviation industry are going to increase comparatively. So as emissions from cars and trains and what have you reduce, because it's so much more easy to do that, because the whole weight consideration is not such a factor, the emissions by aviation are set to increase. In fact, the UK industry body called the ADS, which represents like 11,000 aerospace companies in the UK, they've projected that on current trends that the aviation industry will be the largest polluting transport sector by 2050. And that means that, the spotlight will be on it even more intensely unless it addresses this emissions issue. But I think the good news is that the industry absolutely recognises this. At the Paris Air Show last year, for example, the 7 CTOs of the leading aerospace companies, such as Boeing, Airbus, Dassault, GE, Rolls-Royce, etc., they all agreed to cooperate to address the emissions issues. And it's also recognised by governments. So just recently, the UK government set up the Jet Zero Council with the explicit remit of investigating the technologies that would be necessary to achieve zero emissions flights by 2030. So it's a sort of good news, bad news thing. So a whole host of pressures that are facing the industry with regard to emissions, and that the emissions will appear to get worse. But positive that sort of industry and government recognise that and are highly motivated to do something about it. On the second question, or the second aspect of this, what are the technology challenges? Well, the main issue here is that aviation fuel is almost the perfect fuel, apart from the emissions, the great problem of the emissions, because it's a very, very energy dense fuel. In terms of how much energy you get per weight and how much space the fuel takes up, it's greatly superior to both lithium-ion batteries and hydrogen. So aviation fuel has got 40 times the energy density of current lithium-ion battery technology. So the consequence of that is that lithium-ion batteries are really only a viable technology for quite short-haul flights, unless there's a massive improvement in their energy density. And then secondly, the other potential sort of alternative is hydrogen. Now, hydrogen is spectacular with its energy density. It's 140 times greater than aviation fuel per kilogram. But because it's so light, it takes up 3,500 times more space. So what this means is that you can only really use hydrogen if you compress it, either via high pressures or cryogenic temperatures, which then means you've got a really heavy pressure vessel. So this sort of goes to the heart of the technology challenges. It's about the energy density in terms of energy per weight and energy per space. And currently aviation fuel is fantastic by those measures. And by the way, it's quite cheap. So, that's quite a technological hurdle to overcome, but it absolutely needs to be overcome, and no doubt it will be in the fullness of time. So that's my long-winded answer to Shani. So the challenges are the pressures on the industry and also the very significant technology challenges.
Thank you for that. I mean, that was brilliant, and I think I 100% agree with you. That I love that you called it a perfect storm, because I do agree that at this point, I think it's both government, public, it's investors, it's a lot of pressure on the industry. But I love that you focused it from a very positive perspective. And it is true that although aviation is in the spotlight right now, not just because of COVID, but of all of these sustainability pressures, that there have been many, many, many commitments from the industry and from government to make a change. From your personal perspective and the perspective of the AMRC as a collective, how do you think that the aviation industry can best tackle their sustainability challenges to reach their goal of Jet Zero?
Well, thank you for that. I think there's four areas for me, which I'll sort of elaborate on. The first being collaboration. So this problem is of such a scale and of such a complexity that it can only really be done via collaboration. And by collaboration, I mean collaboration between government, industry, and academia. You need all those components to work together for the government to set the incentives to enable it to happen, both in terms of funding and describing what the challenges are. And of course, academia needs to be brought in to do the heavy lifting in terms of research and development. And of course, we need industry to pull it all together to produce the products. But in terms of collaboration, I don't mean just nationally either. it needs to be international, because it's the entire industry which is potentially under threat. And of course, the aerospace industry has got a long history of collaborating. We can go back 50 years to when the French and the British collaborated on Concorde. And of course, Airbus is a sort of a European collaborative effort. And in the area of aerospace defence, there's numerous international collaborations, from Eurofighter to the Joint Strike Fighter. So answer one, it's about collaboration. Number two is, I think there needs to be this inspiration. And what I mean by that, it's a bit like John F. Kennedy's moonshot speech in 1962. He said, within the decade, we choose to go to the moon. He set, in that case, a really inspirational target for the United States, which completely captured the imagination of the American people and also, American industry. And in fact, this week, the ATI, the Aerospace Technology Institute in the UK, announced its Fly Zero initiative, which I guess is the sort of UK's equivalent of its first moonshot, or the start of it anyhow, where it's launched a feasibility study into understanding the technologies that would be necessary for zero emissions flights. Third angle, this can only be done with the absolute best talent and new and radical thinking. And the thing is, in the last 70 odd years, we've been using jet engines burning aviation fuel. And most of the civil airliners, they're almost identikits of tubes with wings. That kind of architecture and those propulsion systems are not going to be the way forwards. So the question was, how can the industry do it? Well, it needs to absolutely recruit and employ the very best, most free-thinking new talent to achieve this. And then finally, I think we absolutely need to use the full power of digital tools and technologies, because these new aircraft are going to be incredibly complex, and there's going to need a huge amount of modelling and simulation to minimise the cost and time of the physical modelling. The timescales that this needs to be achieved in cannot be done by the conventional ways that aircraft are developed. It's got to be done in an accelerated way using all the digital toolkits that are available. So that's how I think industry can tackle this.
Fantastic. And I think once again, this is very encouraging and inspiring. I think especially for our students listening, who are going to be the new talent that are taking this challenge forward. So to touch on 2 points that you just mentioned on these key pillars or areas to achieve this sustainability goal, if we're looking both into collaboration and about digital tools, so I wanted to ask you a bit more about electric propulsion in aviation. And the more I read about it, the more I realize that it's not a question of if, but rather of when. And when you're talking about collaboration, I just wanted to know, what do you think industry and government need to be doing to further these efforts into making electrification a reality?
Well, that's a fantastic question, Shani. Well, I think government's role is that it absolutely needs to set the right policy frameworks that are going to incentivize industry to invest in the R&D. Because without those clear policies, and it's going to be very, very hard for industry to have the confidence to invest. And secondly, it probably needs to change the tax framework to tip the economics away from jet fuel. Because at the moment, jet fuel doesn't attract any tax, certainly. And it seems quite bizarre that when we fill up at the tanks, we apparently pay about 80% of the price we pay at the petrol station is 80% tax to the government, but there's zero tax on aviation fuel. So these new technologies are going to probably be more expensive in the short term, but only if we consider the existing tax framework. So I think increasing application of carbon taxes is one of the things that government need to do to tip the economics in favour of these new fuel sources. And, we mentioned the moonshot targets. I think they do need to set moonshot targets to inspire both industry and society to get behind these really important programs. And then in terms of industry absolutely needs to cooperate, because this problem is just too big. It requires such a huge range of technical disciplines to address. I do think that industry recognises this, and I've already referenced the 7 CTOs at the Paris Air Show. The whole industry recognises the threat. So I'm fairly confident they also recognise that they can only achieve this via cooperation. And secondly, what does it need to do? Well, invest now. There's no room for delay whatsoever. The industry is facing an existential threat. If this is not addressed, the whole emissions thing, the industry faces the prospect of being radically smaller in the future. So that's what I think government and industry need to do.
Thank you for that. And I was just wondering, because I completely agree that this existential threat, it's become more and more obvious to government and industry. But I think it's also kind of nerve-wracking for students who've always dreamed of entering this industry, and now I think could be potentially nervous, or could approach it the way that you mentioned at the beginning, and it's actually just a great opportunity for sustainability. So if I touch on one of the points that you mentioned, so one of your key pillars again was new talent. So what do you think are the skills that this new talent needs to make sure that they can address such critical threats to this industry?
Well, I think again there's 3 that stand out for me, and I'll sort of elaborate them. One is the technical skills, one's communication skills, and the third is a really cooperative attitude. Now, in terms of the technical skills, apart from being, say, brilliant engineers, and which is a sort of a given, they also, I believe, need to be absolutely proficient in the use of all the digital tools, because the digital tools are key to providing the depth of understanding of in terms of the analysis of the problems and the modeling and the simulation. That is going to be absolutely key to shortening the development times and minimizing the costs for these new developments. So being digitally very savvy is, I would say, an absolutely essential skill for the future engineers. Secondly, it's communication skills. And what I mean by that is that unless these new ideas can be communicated in a really compelling way, then to a certain extent, they don't have value because they won't be heard. So being a really powerful and effective and compelling communicator, I think, is a key skill for an engineer. And I would suggest perhaps an often overlooked skill. There's a lot of focus on the technical capabilities, but unless you can communicate these technical outputs, then they might not be applied. And thirdly, it's this cooperative attitude. These problems and these new engineering teams that they're going to be working in, they're going to be multifunctional teams. They're going to have people from all kinds of disciplines. And so it's going to be really key to be able to work effectively with others. So future engineers are not going to be operating in silos. They're going to be working in multidisciplinary teams. So, the ability to cooperate is going to be a key quality for these future engineers.
I think that's extraordinary advice. And hearing you say this, so focusing on technical skills, communication, and cooperation, those are actually the 3 main aspects in which we will be judging our competitors in the competition.
Spooky.
Yes. So, for example, when it comes to technical skills, so we're judging them on quality of the simulation and design of their idea. When it comes to communication, we're actually going to judging them on how they present their development to us. And then cooperation, it's all about the 3D Experience platform, because the whole point, as you said, is not to work in silos. And what the 3D Experience platform does is it presents one platform for, in this case, students, but in really just teams of all careers to coordinate in this one space. And in fact, we're encouraging students who are joining this competition not just to be engineers, but to be of any profession, because as I agree with you that we really need to work together to make this change. And
Wonderful.
I think another thing that just your answer kind of highlighted why you wanted to do this competition in the first place. We really wanted to give these students the proficiency in the digital tools that they're going to need in the future to make this change. So thank you so much for that incredible answer, and I wholeheartedly agree with everything you just said.
Wonderful. Excellent. I'm pleased to hear it.
So one final thing. So I know that you actually started your degree at the University of Sheffield, and it's how incredible is it that now you're back as the CTO of the AMRC? But I wanted to ask you, so thinking back of your time as a student and the incredible position in which you're now, I just wanted to ask you, what advice do you have for the student teams who are going to be joining us in this competition?
Do you mean from a career perspective or from this competition perspective?
I think both. I think what advice would you give to someone who has always dreamed of going into this industry but now is nervous? And also, what advice would you give a student who is really thinking about entering this competition?
Okay, excellent. So a two-part question there. What I would say to people who are young engineers potentially about to graduate or recent graduates, and they are, let's use the word, fearful about the prospects for the aviation industry, I would say a couple of things. I graduated in 1992, and at that time it was a severe recession, particularly in UK aerospace. What I would say is that in that period, the aerospace industry since then has expanded hugely. And until the COVID hit recently, both Boeing and Airbus have got enormous order books, something like between 8 and 10 years order books. So prior to COVID, it was a fantastically healthy industry. And I've got absolutely every confidence that it will return. But it does face this threat. And really, it needs this new, free-thinking, highly motivated new talent that can apply its skills to address these issues for the industry. So, and it's a really, really exciting and dynamic industry. It's putting several hundred tons of metal in the air and flying it across oceans is really stretching the limits of engineering. And now, not only do we need to do that, fly several hundred tons of metal and composite across oceans, we now need to do it with zero emissions. So the industry had tackled these crazy physics challenges of getting the right power to weight ratios, getting the right energy densities that allow that. So really, we now have this new curveball. How do you do it with zero emissions? So that's the challenge of our lifetime. It's the challenge of this new generation of aerospace engineers. And I've got absolutely every confidence it will be addressed. So that's that question. I hope that covers that one. And then in terms of how to address this particular competition, well, this is about sustainability. It's, the focus has been on future propulsion. But there's much more to sustainable aviation than just minimizing emissions during flight. There's emissions that are created during the manufacturing process. There's emissions created producing the raw materials such as aluminium and titanium and carbon fiber composite. And then there's, what do you do at the end of the aircraft's life? How do you recover and ideally reuse these high-value materials? So whilst the primary focus, from my perspective, is on the propulsion side, it would be great if thought was also given to manufacturing processes which minimize emissions, and also what will happen to the aircraft at its end of life. How will it be dismantled, and how will the materials be recovered and reused? So that's my answer, Shani.
Thank you so much, Stuart. I fully agree with you. I think when we think about sustainable aviation, we really need to think this from cradle to cradle perspective. We need to think about the whole life cycle of what we're producing.
Yes.
And I'm really excited to see what our students come up with. And I hope that they keep this very much in mind. As well as your previous answer, I think you've nailed exactly what they need to present to us to be able to win this competition.
Wonderful. Good.
Thank you very much for joining us today for this podcast. It's been absolutely incredible to get your incredible expertise in this area.
You're very welcome. Thank you very much.
Thank you for tuning in to our Sustainable Aviation podcast series. We hope you enjoyed this episode and that you follow the Dassault Systèmes Sustainable Aviation competition and register your teams. If you are a student registered in a university in the UK or Ireland and want an opportunity to change the world of aviation as we know it by designing a solution in the virtual world on the future of propulsion, for instance, related to the electrification of flights or alternative fuels, then come and join us in this competition. You have until the 11th of September 2020 to register your students or apprentices teams on our website. Just look for Sustainable Aviation Competition Dassault Systèmes on Google or check out our Dassault Systèmes LinkedIn page. Thank you very much.